Hi, thanks for joining me today. I've got a fun summation problem. We want to evaluate the sum from r equals 0 to 99 of 2r squared minus 98r plus 1, all divided by 100 minus r times 100. Choose r. Okay, if you want to have a go at evaluating this sum here, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so the first thing we want to do is just expand out this choose thing here, so 100 choose r, so this is the same thing as the sum from r equals 0 to 99, the top stays the same, but then when we think of this 100 choose r on the bottom, that's 100 factorial divided by r factorial times 100 minus r factorial, so we can bring the denominator of that fraction up to the top, so we're going to get an r factorial there times 100 minus r factorial, and that's all divided by 100 minus r times 100 factorial. Now, this 100 minus r can cancel with this 100 minus r here, so we're just going to get a 99 minus r factorial, like so, and we still got this 100 factorial in the denominator here, but we can just bring that out to the front of our sum. So it becomes the sum from r equals 0 to 99 of 2r squared minus 98r plus 1 times r factorial times 99 minus r factorial. Now we're going to use a nice identity on this thing here. So it's a bit of a leap of faith, but we can notice that 2r squared minus 98r plus 1, this thing here is the exact same thing as if we did r plus 1 squared minus r times 100 minus r. Because if we just start from this right hand side here and expand everything out, we're going to get an r squared minus r squared, so that's the 2r squared there. We're going to get a 2r from this minus 100r, that's going to give us the minus 98r, and then we're going to get a plus 1 from here, which is this plus 1 here. So this is an identity we can use, and what we're going to do is we're going to plug this back in here, and the reason this is very useful is because of this minus sign here. So perhaps if you've seen summations before, you can have a guess as to what we're going to try and do next. Okay, so plugging in the expression we just had, we get that our sum is equal to this thing here. So now what we're going to do is just expand out the bracket. So this is 1 over 100 factorial, nothing changes here. Sum from r equals 0 to 99. Now r plus 1 squared times r factorial, 99 minus r factorial. Well, we can take one of these r plus 1s, join it with the r factorial, and we're going to get an r plus 1 factorial. So the first thing here is going to be r plus 1 multiplied by r plus 1 factorial, multiplied by 99 minus r factorial. And then we're going to subtract off this times this thing here. Now this 100 minus r here times this 99 minus r factorial is going to become 100 minus r factorial. And this r times r factorial, well, it's just r times r factorial. So we have this here times 100 minus r factorial. And now if we have a stare at this for a second, we can notice that this is actually the method of differences, or a telescoping sum. So if we just say f of x equals x times x factorial times 100 minus x factorial. Maybe I shouldn't have used x and should have used n or something. X has to be an integer here. But what we notice is this is just the sum from r equals 0 to 99 of f of x plus 1 minus f of x. Or not x, sorry, r. So let me just change that to an a. So the sum from x equals 0 to 99 of f of x plus 1 minus f of x. Because this thing here, when we plug in x equals r plus 1, we get this thing here. So x equals r plus 1, we get r plus 1 times r plus 1 factorial, and then 100 minus r plus 1 is the same thing as 99 minus r, or sorry, 100 minus r plus 1 is the same as 99 minus r, which is this thing here. So this is exactly this, and now we can do telescoping. So if you've not seen this before, I'm just going to look at this sum here and write out the first few and last few terms. So this is 1 over 100, oh, that's supposed to be factorial, multiplied by this sum here, and let's just plug in x equals 0, so we get f of 1 minus f of 0 plus f of 2 minus f of 1, so that's our second term in our sum, and the next term would be f of 3 minus f of 2, and so on, all the way up to the last two terms, which would be f of 99 minus f of 98, plus f of 100 minus f of 99. And what we notice is that if we look at consecutive terms, this f of 1 here is going to cancel with this minus f of 1, this f of 2 cancels with this minus f of 2, this f of 3 here will cancel with a minus f of 3 there, and so on. This f of minus 98 would cancel with a positive f of 98 here, f of 99 and minus f of 99 cancel, so all we're left with is f of 100 minus f of 0, and quite nicely f of 0 is just going to be 0 because you've got a 0 times something in there, so that's going to vanish as well. So all we're left with is this is a 1 over 100 factorial times f of 100. What is f of 100? Well, it's going to be 100 times 100 factorial times 0 factorial. 0 factorial is 1, so we can ignore that. The 100 factorial and the 100 factorial cancel, and all we're left with is 100. And that there is our final answer. So that, from the crazy summation we started with at the start, with a quadratic in the numerator and some binomial stuff in the denominator, we can actually simplify quite nicely using the method of differences, and we get the answer is 100. Anyway, I hope you have enjoyed this problem. Thank you for watching. If you're new to the channel, please do check out some of my other videos. And if you've enjoyed this video, please do like it and do subscribe if you haven't already. I'm close to 2,600 subscribers and it would be great to hit that before Christmas. But yeah, apart from that, I'm going to stop waffling. Thank you for watching. I'll catch you in the next one. Have a great day.